Greetings. In this video I'll be discussing a hypothesis test for difference in population proportions. So let's say that we have two different populations. So we'll call them group 1 and this is group 2. And each of these groups has its members may or may not have a characteristic. Maybe you could think of this as being men and this as being women. And maybe we're interested in who has a preference for a certain product. So within this population, there is a proportion that have this characteristic. We use a lowercase p to represent the population proportion. And similarly, in this group, there is a population proportion, a percentage of the members of this group that have this certain characteristic. So I'm going to put a little subscript here of 1 and here 2 to distinguish between those. But we may be interested to know if these proportions are the same or if they differ. And so for that we could conduct a hypothesis test. So in our hypothesis test for the difference in population proportions, the null hypothesis is always going to be that the proportions are the same. So population 1 and population 2 have the same proportion of members with this characteristic. Now, the way that you write your alternative hypothesis, so H1, you may set it up to say that the proportion in population 1 is less than the proportion in population 2, in which case you'll end up conducting a left-tailed test. Alternatively, you may end up with an alternative hypothesis that the proportion in population 1 is greater than the proportion in population 2, and that would result in a right-tailed test. And then finally, we have the two-tailed option, where we just say that the proportion in population 1 is different from the proportion in population 2. This is a two-tailed test. And so if we're conducting a left-tailed test, if we have this bell-shaped distribution, we would be looking for evidence on the left tail, whereas for a right-tailed test, we'd be looking for evidence in the right tail, and for a two-tailed test, we would look in either direction. Alright, so in order to test this theory, we need to gather some evidence. So what we'll do is we'll look in population 1 for a sample, and we're going to calculate a sample proportion. So we'll have a count and then a sample size. And again, since all of this information is coming from population 1, I'm going to use little 1 subscripts. And I'm also going to take a sample from group 2 and get a sample proportion there based on a count and sample size from that population. So in order to test these theories, I'm going to look at the difference between these two sample proportions, p hat number 1 and p hat number 2. So luckily, under certain conditions, this statistic is going to be approximately follow a normal distribution. And so I can convert this to a z-score, which I'll call z-test, and by looking at that difference relative to a standard error, and then I can compare z-test to z-critical, which is based on alpha, some level of significance. Once I find the test value, I could also then use that to look up a p-value, and I could compare my p-value directly to the level of significance. First of all, I want to talk about the conditions under which this is an appropriate test. So normally when we're conducting a z-test about a proportion, we want to check and make sure that our p hat times 1 minus p hat times n is at least 10. Now, because we're drawing two samples from different populations, I'm going to make sure that this is the case for both p hat number 1 and p hat number 2, and for sample size number 1 and sample size number 2. I want to make sure that both of those are at least 10. And I also want to make sure that my sample size is less than 5% of the population size. And I'm going to do that in both cases. So N2 is less than 0.05 times capital N2. Now, the way that we can calculate this test statistic is, assuming we're verify these conditions and we feel comfortable proceeding with this strategy. So the formula for z-test is p hat number 1 minus p hat number 2. Now the denominator is a little tricky. It involves this p hat times 1 minus p hat and another square root with 1 over n1 plus 1 over n2. Now this p hat value is the sum of our counts, so x1 plus x2 over the sum of our sample size, n1 plus n2. Now, of course, you can do this by hand, but I want to show you that there is an option in a TI-84. If you look in your stat menu under test, the sixth option is this 2 proportion z-test, so option number 6. So when you use this option number 6, the 2 proportion z-test, your calculator is simply going to need to know values for x1 and n1, and x2 and n2, and then you would have to let the calculator know the direction of the test. So whether you're trying to show that P1 does not equal P2, is less than P2, or is greater than P2. And so, of course, for that you would look in your alternative hypothesis. So in another video, I'm going to show you an example and I'll actually use this calculator feature, and then I'll finish up the hypothesis test by making a decision of whether to reject or fail to reject the null hypothesis. Okay, see you then.